let's get started with, first of all, going over some basic theorems in the limits that's going to help you be able to solve these problems. Just to review here what we're trying to solve or figure out. Everybody usually has these types of questions. If I take the limit as x approaches to 0, say of sine x divided by x, everybody knows that's 1. Oftentimes, students usually have questions where they get slightly confused when, say, what is it if it's sine 3x over 5x? Or what is it as the limit approaches 0 of 5x divided by sine 3/4 x? So what do we do then, and how do we solve these types of problems? Well, it starts off, I'm going to help you guys through this. Hopefully this will be a quick and brief video. We have to understand certain theorems. If I have a function f of x that's equal to a constant, then I have to remember that the limit as x approaches a of f of x is equal to that constant. Now, a lot of times in math you have to ask yourself, well, what exactly are they talking about? Basically, f of x, any function, is equal to a constant. That's like saying f of x is equal to 3, f of x is equal to, say, negative 1,000. Well, what does the graph of that what does that look like? So if the graph is f of x is equal to 3, and this was 3 here, is a constant. So basically, for any value of x that I choose, as I approach that value of x, my values are always going to be equal to that constant 3. So basically, this is saying as f of x, say if f of x is equal to 3, as the limit approaches, say, negative 2, what's my answer? It's going to be 3. What if my limit approaches, say, positive infinity of 3? What's the answer going to be? It's going to be 3. It's a constant. It's always going to be that constant. So, what if my limit as x approaches any value, a, which could be 3, negative infinity, positive infinity, 5/2, the square root of 3, anything, whatever that value is there, it's always going to be equal to that value. That's the first thing we have to realize. Now, for the next things here, we have to remember or use these definitions. As x approaches a, any constant of f of x, we're going to say that limit is equal to a. And we're going to have another arbitrary function as the limit approaches a, say of g of x. Well, this is going to be equal to b. And these are all pretty cool. Basically, if I have the limit as x approaches a of any constant times f of x, basically what this says here, that I can take the constant to the outside. I can just take that out, because we already defined the other time that the limit, and you're going to see this rule come up again, that the limit of any constant is always going to be equal to that constant. And you're going to see how this works here pretty certainly. So I'm going to put a star by here so you can see that. Okay? So we just got to remember that. So since the limit of f of x is equal to a, I got an a here. And since the limit, we already discussed here that the limit as x approaches a for any constant is always equal to that constant. This brings me up to my next theory, that the limit as x approaches a of, say, f of x times g of x is going to be equal to a times b. And essentially that's what just happened here. You can see that there. Or the limit as x approaches a of f of x divided by g of x, guess what that's going to be equal to? Well, if you thought a over b, well then guess what? You're right. What about the limit as x approaches a of f of x plus g of x? And if you said a plus b, then you were correct. Okay? So these are some things to remember. But here's the trick here. B can't be equal for this one, this problem here. B cannot be equal to 0, because for us that's undefined. And so that's something to keep in mind. Those are the major ones. There's one more that has to deal with powers, but I'm not going to worry about that today. Okay? Let's get to the crux of our problem. we know by definition, and I can do the proof for you. It's a great exercise. I won't go through that. Or maybe I'll do a separate video, because oftentimes students have that as homework, and maybe I can give you some hints. I don't want to do people homeworks for them. But generally, when I was taught calculus in high school, I was given the definition: the sine of x divided by x is equal to 1. Okay. Incidentally, once you do the proof, you'll also realize that the sine of x, if it was on the bottom, is also equal to 1. Okay. That's something to keep in mind. So let's get started here. Okay, now, as I said before, the problem comes into play. Let's start off with this problem. The sine of, as the limit as it approaches 0, the sine of 5x divided by 2x. Okay, thing to keep in mind here is that the sine of 3x over 3, say as the limit approaches 0, I'm being lazy here, that's also equal to 1. So we just got to keep that in mind. So I look at this problem, most students scream. If I know this, that as long as these two numbers are the same, it's always going to be equal to 1, then what I want to do is get it into a nice pretty format that looks something like this. Because I'm extremely happy if I can have my problem look like sine 5x over 5x, and I know that's equal to 1. Well, I can do that. We already learned on the prior page that if I have a constant, I can take that to the outside of the limit. So I can say this is the same as saying 1/2 times the limit of x approaches 0 of sine 5x divided by x. Okay. Then what I want to do is I want to multiply the bottom here by 5. Now I can do that as long as I multiply over here the outside, the top, by 5. Those cancel each other out. Because see, if I take this 5 to the outside, then I have 1 and I haven't changed the problem. So isn't that wonderful? Then what I have here is 5/2 times the limit as x approaches 0 of sine of 5x over 5x. I already know that this portion here, that's equal to 1. So I end up with the sine of 5/2 times 1, which gives me 5/2. Beautiful thing. Another example here. This time, oh, black doesn't work for you. Let's say we are looking at the limit as x approaches 0 of 3, excuse me, let's just cross that out. I won't restart the video. The limit as x approaches 0 of sine 3x divided by sine 7x. Well, what did I do? Well, we already discovered that we can break these things up into their own separate division problems. Okay, so I look at this problem and I say, man, I would really, really love for this problem to look something like sine of 3x over x. Okay, and I would like, or 3x here, and I would like this part to look something like 7x over sine 7x, because I know that's 1 and that's 1. So I love that, and I want to do something like that. So let's see how we can make that happen.